Pandemic response questionnaire for 25 million users made in 1 week is the title for my presentation. My name is Hiromu Ogawa. Nice to meet you. First of all, I would like to introduce myself. I came to Line as a new graduate in 2015, and it's been 6 years since then. As a server-side software engineer, I am involved in the development of the Line official account manager. In the past, I worked for the Smart Channel, Line advertisement, Line Point advertisement as development. So have you seen this message? This is the national survey for the COVID-19 messages asking for the responses from the users. So I would like to talk about the background story about this survey. So National Survey for COVID-19 is asking the health condition and then how to prevent the COVID-19 to the Line users. We have done this survey for 5 times so far, and then this responses will be provided to the Ministry of Health and Labor, and then they use it to prevent the expansion of the infection. Let me tell you 3 numbers here. The first one is 83 million. So we have asked 83 messages to the users to respond to our responses. So to 83 million people, we sent this message. And 25 million is the next number. So this is the number of the responses we received from the user. With their cooperation, it's a great number and also good response rate to the messages we sent. And number 3 is 6. So this might seem a small number compared to the first 2, but since the project got started, and we spent 6 days until we were ready to do the national survey. Why could we develop these in 6 days? And why was it necessary? So 2020, March, we did the first survey. And COVID-19 infected people's number is increasing in those days. And in the cluster team of the Ministry of Health, they needed to have the data so that they can use it to address this problem. And then there was an emergency announcement on the April 7th. From the end of March, the number was increasing, the affected infections number. So project started on March 25th, and the same day, the Tokyo Metropolitan Government asked the people to stop going out unnecessarily and urgently, and we wanted to do something to help this cluster team at the ministry. So the data was really important and required. So we thought what we could do, and we thought, why don't we do the national survey? So Line has a contacting point with a lot of users. So through Line, we should conduct the necessary survey so that we can get response data in a very short period of time. That's what I thought. And this is unprecedented, and there was a risk of failure. But this is the survey only Line can do. So we felt like we have the social responsibility. So we are not particularly asked by the ministry, but we took the active lead to do this survey. So at this survey, what kind of method would be favorable, we thought. And we thought about the 3 methods. The first method is that to use the Line research system to do this survey. If we could use the existing system, we can do the survey very quickly. But line research service is suitable for the hundreds and thousands people's survey, but it was not there for the national survey. So we had to think about how we can cope with the load issue. And secondly, we thought we could work with the other companies who is doing the ankete questionnaire system. We didn't look into this method in detail, but compare it to the internal communication. External communication may take time, and we wanted to conduct this survey very, very rapidly, so we did not take this option. Number 3, to develop the completely new system. Then, of course, it's not easy. But compared to make some fixes and update to the existing system, if we started quite a new project, there will be no limitation, and we can focus on the important features for this survey. So we took this option for the rapid survey. So this is a timeline from the start of the project to the execution of the survey. In the 6 days, we created the specifications and then QA before release. All the tasks are included in this time frame. So in terms of the system development period, we had only 3 days substantially. So let me introduce the team for this development. We had one server-side engineer, and one front-end engineer, and a planner, one planner, total 3. Of course, these are not the people we had. Infrastructure, security, data scientist, DBA, and related service engineers. These people, of course, helped them to realize this project. But these are core members, and we had a small team so that we can do the rapid development. And product management and the front-end development. We have a lot of presentations published or interviews, articles are available. So if you are interested, please take a look at them. And today, we would like to talk about the server-side development mainly. And there were many challenges in this development. First of all, we need to get a lot of data quickly. So we had to establish the system as soon as possible. In addition to that, this is a national survey for all line users, and we could expect a lot of responses might come in. And then we need to create a system to handle those many responses. And in that case, the system should not be stopped because of some kind of troubles. If there is a system trouble, there will be a lot of impact to the users who are cooperating in this project. And that will damage our trust. But not only that, that will give the very negative impact to the society as well. So with those challenges, we really wanted to complete the system and release it, but that was not easy. And in this situation, we thought about the 3 points. The first point is that we need to implement the minimum necessary specifications to make the system very simple, because the time is limited, so there is certain things we can do. And then in order to make system realize, we need to screen down on the implementations. And secondly, we decided to take the phasal approach of the development. So keeping the system and then make the phasal approach so that we can do the development.
In this project, at the development start, specifications were not finalized, but we didn't have time to wait for the finalization. So the specifications were defined in parallel to the development, and then by monitoring the progress status of the development and how far we can finalize the specifications was the only approach we were able to take. Thirdly, we tried to avoid as much as possible system trouble in the design stage because of the short period of time for development, and there were more chances for us not to be able to elaborate fully the components compared to usual development. However, we needed to work out somehow we can avoid visible system troubles. Now I would like to introduce to you system that we actually developed. First, as a first stage, and mechanism to display the survey page, and also a mechanism to save answer data. Before talking about this system, I would like to briefly explain you the flow when user answers to the survey. First, user receives the message that you can see on the left-hand side. In this message, there is a request for participating to the survey, and there is the first question included. In the chat room, when user answers this first question, then the survey page is displayed so that user can answer other subsequent questions. The survey page was designed as if it were an application functionality within the in-app browser of Line app applications. This is being provided by a live platform, so no additional development for the app was required. When on the survey page and answers are completed, thanks page is displayed. So that's the flow for user when the user answers the survey. In order to materialize these functionalities and features, the first idea that we had is this type of system. Based on the master data of questions, a survey page is to be displayed, and that's one feature. And another feature is to receive the answers to store them in some type of storage. But we had some concerns about this configuration. First, we were not sure if we can implement the applications in time. In addition to that, the application implemented in a short space of time didn't seem to be able to handle comfortably high traffic. So given the limited amount of time available for us, we needed to reduce the amount and the volume of implementation. This was in order to reduce the time for implementation, as well as to have an expectation less to have unexpected behavior with less new codes. So this is the first stage system that we created. Actually, we tried to prepare as quickly as possible to certainly and stably handle a lot of traffic. We decided as a result of that build the system with the NGNX at the center. Because of the traffic related track record of NGINX, we thought that we were able to comfortably handle the traffic with a minimal verification. And then first in the survey page with the answer form, server doesn't sends back as just a static HTML, and then we didn't store the contents of the questions in any specific database, and they are hard-coded within the page. And then this time we needed to switch the page questions depending on answers of the users, but that was just handled by JS, so that we don't have to separate them on the server side. When the user finishes answering, there is a request to send answers to the server. We decided to process this sending by two steps. First, the answers are sent on the timing of the opening of the server page, the questions are sent from within the message, and along with the timing on real-time basis, so when user answers questions, answers are sent, so that even if a user drop out during the course of answering, the answers are never lost. And we use the NGINX to store and save the received answers. You may wonder how we did that. This time, we wrote out the contents of the answers as part of access log. Originally, for all requests, access logs were generated. So compared to file delivery in a static manner, there is almost no extra overhead. I think this type of method was quite unusual for you. However, within our organization in Line, we have already have experiences with a similar approaches to receive event logs on ad platform from server side. So we adopted this. And access log NGINX, in order for greater ease of counting later on, we decided to generate it in LTSV format. And the point here is to how we save the request body. In terms of requests from clients, we packed in JSON format into the body of the post request. And this is saved as is, as LTSV field. If you look at actual logs, you can see that even though some of the signs were escaped, but the JSON is saved as is. By doing so, even if the question's contents are changed, NGX setup doesn't need to be updated. Question contents were finalized at the very end in parallel to development. So from the server side, we did in a way that the server is not to be affected by the change of the contents of the questions, so that it can be dealt with by client and analytics side only. So far, we were able to mainly focus on NGINX to display the server page and save answer data. Next, we implemented the aggregated part of the answer logs. In the first stage, access log, which are answer data, were wrote into the disk of each of the hosts of application servers. In order to aggregate as a finalized survey results, in a way or another, they needed to be aggregated from all of each logs into one single location. Log aggregation can be done after the survey. So we considered to do that only with the first stage built system. However, we decided that we needed to do that more in a real-time way when we are considering a specification. So we decided to implement disaggregation. There were two main goals. One is monitoring. By being able to constantly check the accumulation status of logs, system trouble were able to be detected, and this can help almost stabilize execution of survey. The second is to the utilization of this in order to maximize the number of answers. We can implement the actions such as analyzing logs or using other routes and channels to send to only some limited users updated questions. And then we used Fluentd for real-time log collection, and log aggregation destination was MySQL, because we thought that if MySQL, it will be able to do easily counting by writing SQL, and that was useful for monitoring. And then Fluentd is monitoring access log updated, being introduced in each of the hosts of access application server, and then it inserts once every second the additional logs. And by utilizing Fluentd, access log reading can be done in asynchronous manner vis-a-vis log aggregation processing. And by doing it in an asynchronous manner, when there isn't a problem on the side of the collection of the logs, users can still participate in the survey. And Fluentd setup was this type of pipeline. And they plug in access log and LTTC is parsed.
And next, using the record transformer filter plugin, we put it back to from the escape, and then we parse the request bodies JSON, and finally, using the Fluent plugin MySQL, we insert the necessary field from the LTSV and the JSON. In the request body, we have the user ID and the other responses, other data other than the responses. So we take out those information and put it into the dedicated column. That is the purpose. So as a response data, the serialized JSON would be inserted as it is. So by doing so, the insert portion from the Fluentd to MySQL that should be very robust to the changes of the type of the questions. And then as a third step, verifying log and filtering process was added, and implemented. So we could collect the access log, but in this stage, request is not verified at all, just aggregated. So final survey result, each log request should be verified if it is a legal one. And if it's not, then we need to do the filtering. And furthermore, in this survey, user can answer to the questionnaires many times. And in that case, the very last response should become the valid one. That was our specification. So when we receive the responses, using the NGX, we store the response as an access log. So before that, we could not check whether this user had already answered the questionnaire. And that's why to those response data, we can do the check afterward so that we can do the filtering of the duplicated users' responses. In this verification, it was not essential to do this real time, but monitoring can be done more correctly. And then implementation was not so difficult. That's why we decided to use the near real-time verification. And this one is a system architecture, including the third stage function. So in order to identify the user who already answered the questionnaire, on the client side, we did the verification or the authentication using the line login. So LIF is used for the web application, and you can open it from the general browser. And if you want to open it in a line application, it could get connected to the application. So user do not have to make any special operation. Being logged in, they can answer the questions. So at the time of login, ID token is issued and sent back. So at the time we have the event sent, we tried to send it to the server. ID token is the JSON web token, including the user data and the signature. So issued ID token can be verified using the public key, so that this token is a legitimate one or not. So ID token has an expiration period, so you can verify it in a later stage. And in addition, if we get the public key from the ID token issuer, you can just do the verification on your desk just by doing the computation. So ID token would be stored in the database, and then that ID token can be verified asynchronously. So that is possible. And the ID token sent by the client needs to be verified. We prepare the batch server, and then we put an application on top of that. So this application will fetch the access log, which is stored in the MySQL, and then verifying the ID token in the access log, and then a result would be written back to the another table of the MySQL. So we're going to check if the user already answered the question. If so, we overwrite the original answer. So it gives a lot of load to the CPU. So we didn't use the application server. We had a separate server and do it in the asynchronous manner so that we could minimize the impact to the user, to the request from the user. So we had made this preparation, and then other than the system implementation, what did we do to prepare before we start the questionnaire? So first of all, this is message delivery about the survey page. So most of the inflow is from the messages. So in order to have the control of the traffic, it was important to think about the message delivery. As I said before, in this survey, we asked this survey for 83 million people. So we delivered the message, and then internally, it is not reaching all the user at one time. So the delivery and the notification is done per user. So depending on this the delivery pace, the response pace is also changes. So when you look at this diagram, we had the same number of users, and then slow delivery and faster delivery are compared in terms of the increasing number of the responses. So even though we send the same number of messages, but if we do the faster delivery, then we have a big spike in responses. And if you do the slow delivery, the increase of the responses is slow, and then we can control the peak traffic. And then the survey page should be able to process a lot of requests, but the project cannot accommodate any failures. So we thought we should suppress the peak time traffic. So if we deliver the message internally, we sometimes think how we can suppress the delivery pace. But this time, not just account friends, we deliver this message to all users. So we have to think of something different as a system. So but this system did not have the suppressed delivery pace. So we thought about maybe we could make some fix. But this time we decided to do the manual control of the pace. So we divide the users list into several groups, and then deliver these messages in a pseudo manner, slowly pace. So by doing this, compared to the one-time delivery, we thought we could make the peak time spike very small. And by dividing the users into the groups, we might have the operational risk. But this time, the development time was so short. So maybe if we try to make some fixes, that might have a bigger risk than the operational risk. So the survey page, and we did the performance test, but the time was very limited. So not the system as a whole. We did a simple test for just one host.
As a result of that, we were able to confirm that at least, and with no problem, we were able to handle about 1,000 requests per second. For the part to request a request, and it was just the delivering a static file with an NGI and X, so the performance should scale out in addition to the additional instances. So based on this, we considered how many servers will be required. However, it is unprecedented, so what was unknown was how many would be the number of accesses. Just as a thumb of rule, we decided to base on one past record of 25,000 requests per second. So we decided to double it to be based on 50,000 requests per second. So we prepared 50 instances in advance. As for the traffic, as I said earlier, that is affected greatly by the pace of message delivery. This time we decided to do the message delivery manually. So operation team and development team cooperated with each other to do constant monitoring to adjust the pace of delivery and an enhancement of infrastructures. As for the system monitoring, we used Prometheus that we were already always using. First of all, in each server, node exporter or other existing exporters were introduced so that the basic metrics can be exported. Plus, we decided to generate a certain number of service-specific metrics. As for the processing status of batch to verify the logs, we decided that it's to be done batch program itself when the actual process is done. Total number of the logs accumulated in MySQL is to be counted by issuing query toward MySQL's replica. And these service-specific metrics were easier to be pushed rather than implemented as exported, so we decided to send them via push gateway. Based on the metrics collected, aggregated in the Prometheus, we built a dashboard with Grafana, and we set up an alert with Alert Manager. Also, this was not existing at the time of the first-time survey, and it was implemented after that. We built a mechanism to acquire the number of answers via API from Prometheus and to send a notification with line notify. This is the Grafana dashboard and the line notify based notification. Grafana is mainly expected to be checked by the developer. With the first few number of answers and the increased status of answer numbers can be displayed so that at a glance, the developer can check that the survey is ongoing with no problem. If there is any concern, a scroll can be done, the dashboard screen can be switched so that the details can be checked and looked into. Line Notify is regularly notified to the group of all the stakeholders so that they don't have to proactively check that, but can constantly understand the overview of the status. It's a simple design. However, we were able to share the numbers across the team, and then communication was also triggered thanks to that. With all these preparations and the day of the survey arrived, so I would like to show you the metrics at the time of the survey to share with you what happened on that day. So that was the status of the answers on the day of the delivery of the questions. In these graphs, number of answers and the number of total events aggregating the answers to the first questions and then answers to the final through final questions, and also the fluctuation, the number of events during 1 second. We did a small-scale message delivery at 10 a.m. on 31st of March. After that, after the monitoring and the final check, we started the full-fledged message delivery in the afternoon. The number of events within 1 second appears like a big mountain, but you see that sometimes the number of events are lower during 1 second. So you can see that message delivery was divided. At the peak time, it was up to almost 5,000 events per second in terms of within a second number of the event. If we hadn't divided the delivery, the spike instantaneously would have been much higher. After the delivery of the message, the number of events decreased very rapidly, and throughout these 2 days, we were able to complete the survey with no trouble. And the final number of answers were approximately 25 million, and the number of events 66 million. However, as a matter of fact, on the back end, some of the processing had some delay. This was on the first day of the survey, and this is the evolution of delay which happened with the ID token verification processing. The number of events within 1 second displayed along with that is the same as the previous slide. And the number of events during 1 second increased within progress of the delivery, and when it reached 2,000 per second, the delay started to happen, and then for one moment, 3.5 million events were waiting for the processing. And along with the decrease in the number of the events after that, the latency were gradually resolved as well. We considered to lower the pace of the delivery so that we can avoid a delay, but we wanted to avoid a notification to be sent to users in the late night, and also it risked also to be overlapped with the line traffic peak itself. So we decided to tolerate this delay, and we prioritized an earlier finishing of delivery. If we had been doing in a synchronous way within the requests from users, including the IT token verifications, then the delay would have been much worse, and we were perhaps not able to receive the requests in the worst case scenario. But by doing so in an asynchronous way, we were able to avoid to have an impact on users, and despite the short time of preparation we had. Now I'd like to look back from the beginning of the policy definition about this project. First, by creating a system with minimum specifications, we were able to narrow down the features which allowed to implement in a way that NGI NX only can process a request with high performance and stability. And then by doing development step by step, we were able to complete the first visible part in the first instance, and then we were able to step by step build the mechanism on the back end, and we were able to build the system in a certain way with a lot of uncertainties. In terms of avoiding system trouble through design, we decided to introduce asynchronous processing, and then even if some of the components didn't work as expected, we were able to avoid an overall impact. And also, although we had some delay in the ID token verification processing, we were able to avoid any visible impact on users. This is a wrap-up. About the COVID-19, we conducted this survey with a 3-day development period, specification definitions and QA, and in total with a preparatory period of 6 days. 83 million users received the messages from this survey, and 25 million answers were collected. So this was a large scale, but the system was very simple. By designing in a simple way, we were able to make both compatible short-term development and stable processing of many traffics. Thank you very much.